Hi, I'm Ms. Fung. Today we're going to look at average rate of change. Here we have a graph with distance in meters and time. What happens if we describe this car over here, which is moving at a constant rate? Or in other words, it moves at the same speed. Then we can have a straight line describing as time passes how far it has traveled. We call this constant speed, and we can calculate it using the linear gradient method, y2 minus y1, x2 minus x1, and it works out to be 60 km per hour. What happens, however, if most cars don't travel that way? Most cars would travel and slow down and stop, and then speed up and slow down and stop. So most cars do not travel in a straight line. They travel in a line that looks somewhat more like this. How would we describe this? Well, we can calculate that, we can notice that it is not a constant speed, and the rate of change, or the gradient, is variable, meaning it changes. So we find the average speed instead. So not the exact speed, but the average speed. And to do so, we take the total distance over the total time. So in this case, the average speed, let's say we have 300 over 300. So the average speed of this whole path that the car took is 300, or the change in y, over the change in time, which is 60 minus 0 is 60. So 5 meters per second. So the second car traveled on average 5 meters per second. So when we say average rate of change, we're referring to the gradient. Example 1. Here we have the graph that shows the movement of a cyclist on a 16-kilometer training run that takes a total of 70 minutes to complete. Let's have a check. It takes 70 minutes, and he rides from away from a spot to 8 kilometers and then rides back another 8 kilometers. What is a rider's average speed between OC and OE? So between OC, so we're going away up to 8. It took us 40 minutes. So we do 8 minus 0, so the y2 minus y1, and 40 minus 0 for x2 minus x1, and we obtain 8 over 40, or 1 over 5, or 0.2 kilometers per minute. Now do notice that we can convert this to kilometers per hour by, well, 0.2 is 1 over 5. So if minutes is at the bottom, then how do you convert minutes to hours? You divide by 60 to get to hours. And because it's on the denominator, when you divide, so it's dividing, then you put it to the top by multiplying. So we end up with 60 over 5, which is 12 kilometers per hour. You might want to revise that if you've forgotten how to convert units. How about O to E? Well, we know in the story that it's traveling 16 kilometers. So from here to here, he's traveled 16 kilometers, and it took him 70 minutes. So that is, and then if we multiply by 60 to convert to hours, that is 13.71 kilometers per hour. For any function, y equals f(x), the average rate of change of y with respect to x over the interval ab is the gradient of the line through a f of a, or the x value a, and the y value found by f of a, and b f of b. So the x value is b, the y value is found by putting f of b. And we call this the secant. So the average rate of change is called the secant. So between two spots, let's say we pick two spots, to find the average rate of change, or the gradient between those two, we draw a secant, which is that blue line there, and we pick the two x values. So if x value there is a, then the y value will be f of a, and if the x value there is b, then the y value will be f of b. And we do our usual y2 minus y1 over x2 minus x1. And in this case, if we look at these letters, it will be fb minus fa over b minus a. So remember that formula, and do recall that's exactly the same as y2 minus y1 over x2 minus x1. If you've forgotten what a secant is, here's a quick recap. That line there is called a secant. What do you call a line that goes from one spot to another spot without crossing? That's called a chord. And a line that just touches is called a tangent. Example 2. Find the average rate of change over the interval f of x is 2 over x minus 3 plus 4 between 4 and 7. So we have to find a y value. So the y value for 4, we'll plug it in, f of 4. So 2 over, wherever we see x, we put 4. 4 minus 3 is just 1. So 2 over 1 is 2. 2 plus 4 is 6. Then we have to find a y value at 7. So f of 7. So 2 over 7 minus 3 plus 4. 7 minus 3 is 4. 2 over 4 is a half. So we have 4.5. Now we can apply our formula. So f of b minus f of a over b minus a, or 6 minus 4.5 over 4 minus 7, which is a half. Sorry, negative a half. Example 3. Find the average rate of change of y with respect to x between the points a and b. So here we have the 2 points. So the average rate of change again is that formula. So 14 minus 5 over minus 1.5 minus 2, which gives us minus 18 over 7. Now remember from linear that it doesn't matter if this is x1, xy1, x2, y2, or if this is x2, y2, x1 and y1. Just make sure you don't confuse them. Thanks for watching. I'll see you next time. Bye.